So why did it take so long for plate tectonics to be conceived of and accepted as a scientific theory? Well, let's go back to how it all started, right? If you look at a world map, it's pretty easy to notice that a lot of the continents seem like they could fit together like puzzle pieces, right? It seems like that the northwestern portion of Africa could very easily fit into the space right beside North America. It seems like the pointy bit on the eastern side of South America could fit very smoothly into that same shaped indention in Africa, right? They seem to fit together like puzzle pieces. This observation led to the hypothesis of a single supercontinent, a single landmass that composed most of Earth's continental crust. And this idea was conceived of in the 1800s. Okay. Now, in 1915, a German geographer and meteorologist, Alfred Wegener, argued again for the existence of a past supercontinent that he called Pangaea, which translates literally to all lands. Okay. Pangaea was actually made up of two different portions. The top portion that contained what is now North America and Eurasia was called Laurasia, and the southern portion, which included everything else, was called Gondwanaland. The ocean around Pangaea was called Panathasia, meaning all seas. Right? So Wegener put together this hypothesis that all of the continents used to fit together into one supercontinent that he called Pangaea. However, in Wegener's hypothesis, he proposed that the continents were able to drift around and move apart by basically bulldozing forward through the oceanic sea floor. Right? He thought of the continents as bulldozers just pushing their way through the seafloor. And he thought this might be able to cause the Earth's surface to crumple and produce mountain ranges. As we know today, his hypothesis wasn't completely correct. And this is very common with first hypotheses. That's why we have the scientific method that allows us to do iterative tests and perfect our hypotheses. Now, his hypothesis on continental drift was sharply challenged by the scientific community at the time. The chief criticism was that people didn't believe that continents could actually bulldoze through the solid, unyielding oceanic crust. It didn't make sense. That mechanism didn't make any sense. So even though, right, they agreed that it looked like the continents used to fit together, they didn't agree it was physically possible for them to have once fit together and then moved apart. But it was really hard to deny the evidence. Right? Not only was there evidence that the continents used to fit together based on their shape, there was also a lot of other evidence, such as there being similar rocks of similar age found on the continents in the same way they seem to fit together, right? It seems like Africa used to fit in between North America and South America. Well, if you put them all together like puzzle pieces, you see the same type of rocks on both sides of those boundaries, the same age rocks on both sides of those boundaries. It really does seem like it's not just a puzzle piece that fits together, it's a puzzle piece that has the same picture on both sides. Okay. Not only the rocks, the mountain ranges did a very similar thing, right? The mountain ranges that we find in North America are of the same composition and the same age as the mountain ranges that we find in Africa and Europe. Again, the puzzle pieces don't just fit together. They don't just have the same picture on them. They also have the same texture. Okay. Additionally, we find glacial till, which is the sediment that is churned up by the movement of glaciers. We find glacial till on continents that seem to have once fit together, right? South America, Africa, India, Antarctica, and Australia. Based on their shape, they seem to have all fit together at one point. And we see glacial till on all of them as if they were all covered up by the same ice sheet. Not only this, we also see glacial striations. Glacial striations are grooves, scratches in the Earth's surface that are created when glaciers scratch, rub, move over the Earth's surface. And just like we find glacial till on all of these continents, we also find glacial striations on all of these continents. Another line of evidence that shows, yeah, all of these continents used to be connected. Now, finally, not only do we see glacial till, glacial striations, showing that continents used to be combined, we also see the same fossils on these continents, right? We find, for example, Cynognathus, that fossil, both on South America and Africa, as if these continents used to be combined. We see the fossil of the Mesosaurus on both South America and Africa, as if these continents used to be confined. So fossils also support this theory of continental drift. However, even with all of this evidence, the theory of continental drift still doesn't have a mechanism that explains how the continents actually moved, right? What is causing continental drift? How is it possible for entire continents to move around through rigid oceanic seafloor? More evidence was needed before this theory was actually believed. And at the time, right, in the 1950s, this theory was out there, but so were like 20 or so other theories on how the continents moved around. And this one, at least in America, was really laughed at. If you had brought up the idea of continental drift in America in the 1950s, you would have been laughed out of the room because nobody believed it was physically possible. That was until one of my heroes, Marie Tharp. Marie Tharp was an American geologist. She was also an oceanographer and a cartographer, meaning she made maps. And she was the very first person to make a detailed map of the entire Atlantic Ocean floor. She did this in 1953. And when she did this, she discovered that there was a ridge that went down the center of the Atlantic Ocean, which we knew about before. But what she specifically mapped and what she specifically discovered was in the center of that ridge, there was a V-shaped valley that ran all along the center of that ridge, the apex of that ridge. She termed this a rift valley, and she believed that this was where the oceanic crust was physically being ripped apart, where new material from the mantle was welling up, being projected, being released onto the ocean floor through that rift valley, pushing the older material away. She found the mechanism that allowed for continental drift. It wasn't that the continents were plowing through the ocean floor. It's that the ocean floor was physically separating, pushing the continents away. Okay? So you could start with a single continent like Pangaea. Mantle convection, where warm material in the mantle rose up, would thin that continental crust, causing fractures and breaks. When that mid-ocean ridge was created and that rift valley inside of it allowed material to well up onto the ocean floor, creating new ocean floor, it would push the old ocean floor away, creating a wider and wider and wider ocean where the material gets older and older and older the farther you go away from that mid-ocean ridge. Okay. Now, Marie Tharp, she mapped the Atlantic Ocean and proposed this idea of a rift valley in 1953. However, during this time, women were not respected as scientists, right? They were not a part of the professional scientific community. She was just a map maker. She wasn't the person actually collecting and publishing the data. So when Marie Tharp suggested the idea of a rift valley in the Atlantic Ocean, her hypothesis was dismissed as girl talk, not just by the broader scientific community, but also by her closest colleagues, the people who had actually collected the data that she mapped. They called it girl talk, and they said she needed to do it again because she must have messed up. She did it again. She found the exact same thing, and it took her a long time to convince even her colleagues that she was correct. Now she's credited with creating one of the first comprehensive maps of the ocean floor, and she's accredited with finding the mechanism for plate tectonics. But it took her 20 years to be properly acknowledged by the scientific community. So she mapped this rift valley in 1953. It wasn't until the 60s to 70s that she became acknowledged for this huge discovery.